So this year, year 2 of your course, this is the Advanced Maths course, although I think it's been giving another name now, hasn't it? Sorry? Advanced Maths, is it? Okay, right. So this year we're going to be looking much more closely at functions. It's all to do with functions. Exploring functions. E.g., we're looking at the textbook, y equals 7x to the 4. Using the notation, the function notation, f(x) equals 7x to the 4. In some ways, this second way of writing it is more useful because f means function, but actually we can use any letter. So here's another example of a function. gt equals at cubed, something like that. Okay. Without me having to tell you, looking at this, then you know that t is the variable. T is the independent variable in this function. You remember we have two variables that we're interested in a function, so we can plot a graph. The independent variable and the dependent variable, which in this case is g. So if I were to plot a graph of this, I would plot g on the y-axis and t on the x-axis, and I'd get a picture of how the function g, which depends on t, changes with t. And you automatically know that any other letter in this function, which is to a variable, but in this particular case, that particular letter would be constant. Okay? It wouldn't change. So we're investigating how t varies with the function. And how do I do it? I multiply, I cube the t and then times by a. So this one, it's telling me that x is the independent variable. That's the thing that's changing. Any other variable would be constant. So this might have been a, which has been set at 7. And I'm going to find the fourth power of my variable and then times it by 7, and I've got a function. So if I plot a graph of that, I'll see what that function looks like. And that's what I've done on autograph. So if I go to autograph and plot that function, here it is, y equals 7x to the 4, it will look a bit like that. When I do something to the power 4, because it's an even number power, then it's always going to be positive. Because squaring, it's always positive. Cubing, it can go negative. To the power 4, it goes positive. So that's one of the properties of a function like this, is you only get positive values. And there it is. Notice that unlike a quadratic, it goes a bit flat at the bottom here. That's correct. Yeah, this is not parabolic. I don't think this has got a particular name, the quartic function. It looks a bit like a parabolic function, but it's flattened at the bottom. And what this is going to be all about is investigating these functions. We're going to use calculus to find out things like what's the gradient of this function at the point. How would I do that? Differentiate it, right, Mason? I might want to know what the area underneath this function is between two particular points. How would I do that? Integrate it, okay? This might be a particularly complicated function, so that it's not solvable easily using calculus. And so then I might use numerical methods to investigate it. So look at functions, more complex functions, solve them using numerical methods. I can also use numerical methods to find the area underneath the curve. That's useful because sometimes I've got a particular shaped curve and I don't even know what the function is, but I can still sketch it out and find the area underneath by just dividing it up and using some numerical method to do it. So we'll be looking at calculus to investigate the function. We'll be looking at numerical methods to investigate the function. And then finally, we'll be looking at differential equations, which are equations that involve differentials, and solving those to end up with the function that you can then look at and plot on autograph and investigate. So it is all about investigating functions this year. So the first thing I'm going to do is to review some calculus techniques, differentiation and integration, to investigate these functions, and then we'll move on and look at some numerical methods. Okay? If you look at the website, when it goes up there, then you'll see the scheme we're going to follow this year, and you'll also see the lecture notes, and I'll put this lecture note on there. So I'll finish, because I've got to finish, because people start to collect outside. So we'll think about finishing now.
Are you going to put that stuff on that website?
Yeah.
I think you might use the UCS website. So that pretty much does everything, right?
Well, I'm following Mike's lead and doing the using Google Sites to do this. So look at Google Sites, and you can see what we'll be doing on there. So if I just show it to you, favorites, Google Sites, make a note of this particular web page. So you're going to go to the eng operations, I think it's that one, yeah, that you're interested in. Engineering mathematics, advanced engineering mathematics, this is the one. Yeah, that's the beauty of this. You don't need to log into the StudentNet or onto UCS, which is why we're using this, Daniel. You can just go straight to this web page. Make a note of it, please. And get back on here again. There it is. Now, if you're in the college, you need the full thing, apparently. Well, this is what you get in the full thing, but somebody's told me that they couldn't get onto the website outside the college, and we found out that the reason was because you don't need the first bit. So you just put in sites, www. So once you're into Google, just Google sites.google.com/site/this. Quite an awkward web address, so make sure you transfer it correctly.